Hello there, guys. So, today we're going to talk about the classification of binary stars. So, binary systems composed out of stars. A detailed understanding of the structure and evolution of stars requires knowledge of their physical characteristics. We have seen that knowledge of black body radiation curves, spectra, and parallax enables us to determine a star's effective temperature, luminosity, radius, composition, and some other parameters. However, the only direct, and I repeat, the only direct way to determine the mass of a star is by studying its gravitational interaction with other objects. Kepler's laws were used to calculate the masses of members of our solar system. However, the universality of the gravitational force allows Kepler's laws to be generalized to include the orbits of stars about one another and even the orbital interactions of galaxies, as long as proper care is taken to refer all orbits to the center of mass of that particular system. Interesting stuff, correct? Fortunately, nature has provided ample opportunity for astronomers to observe binary star systems. At least half of all stars in the sky are actually multiple systems, two or more stars in orbit about a common center of mass. Unfortunately, our solar system is composed out of just one star, so it's a pretty lonely system. But that's fine. Some analysis of the orbital parameters of these systems provides vital information about a variety of stellar characteristics, including mass, something we really care about. The methods used to analyze the orbital data vary somewhat depending on the geometry of the system, its distance from the observer, and the relative masses and luminosities of the components. Consequently, binary star systems are classified according to their specific observational characteristics. So, firstly, we have the optical double. These systems are not actually binaries at all, but simply two stars that lie along the same line of sight. For example, they just have the similar right ascensions and declinations. As a consequence of their large physical separations, the stars are not gravitationally bound, and hence the system is not useful in determining stellar masses. Secondly, we have the visual binary. That's a system in which both stars in the binary can be resolved independently. And if the orbital period is not prohibitively long, it is possible to monitor the motion of each member of the system. These systems provide important information about the angular separation of the stars from their mutual center of mass. If the distance to the binary is also known, the linear separations of the stars can then be calculated. Next, we've got the astrometric binary. If one member of a binary is significantly brighter than the other, it may not be possible to observe both members directly. In such a case, the existence of the unseen member may be deduced by observing the oscillatory motion of the visible component, so the brighter star. Since Newton's first law requires that the constant velocity be maintained by a mass unless a force is acting upon it, such an oscillatory behavior requires that another mass be present. Next, we've got the eclipsing binary. Very interesting. So, for an eclipsing binary that have orbital planes oriented approximately along the line of sight of the observer, one star may periodically pass in front of the other, blocking the light of the eclipsed component. Such a system is recognizable by angular variations in the amount of light received at the telescope. Not only do observations of these light curves reveal the presence of two stars, but the data can also provide information about relative effective temperatures and radii of each star based on the depths of the light curve minima and the lengths of the eclipses. The details of such analysis can be discussed later on. I can make a separate video about this if you guys want to. So just leave a comment below and maybe I can make a video about it in the future. Now moving on to my personal favorite classification of a star binary, the spectrum binary, which is a system with two superimposed, independent, discernible spectra. The Doppler effect causes the spectral lines of a star to be shifted from their vast frame wavelengths if that star has a non-zero radial velocity. Since the stars in a binary system are constantly in motion about their mutual center of mass, there must be necessarily some periodic shifts in the wavelength of every spectral line of each star. Well, unless the orbital plane is exactly perpendicular to the line of sight, of course. It is also apparent that when the lines of one star are blue shifted, the lines of the other must be redshifted relative to the wavelengths that would be produced if the stars were moving with the constant velocity of the center of mass. However, it may be that the orbital period is so long that the time dependence of the spectral wavelengths is not readily apparent. In any case, if one star is not overwhelmingly more luminous than its companion, and if it's not possible to resolve each star separately, it may still be possible to recognize the object as a binary system by observing the superimposed and oppositely Doppler-shifted spectra. Even if the Doppler shifts are not significant, if, for example, the orbital plane is perpendicular to the line of sight, it may still be possible to detect two sets of superimposed spectra if they originate from stars that have significantly different spectral features. And lastly, we've got the spectroscopic binary. So here, if the period of a binary system is not prohibitively long, and if the orbital motion has a component along the line of sight, a periodic shift in spectral lines will be observable. Assuming that the luminosities of the stars are comparable, both spectra will be observable. However, if one star is a lot more luminous than the other, then we're going to have some problems. These specific classifications are not mutually exclusive. For instance, an unresolved system could be both an eclipsing and a spectroscopic binary. It is possible. It is also true that some systems can be significantly more useful than others in providing information about stellar characteristics. Three types of systems can provide us with mass determinations. So obviously we've got the visual binaries combined with parallax information, visual binaries for which radial velocities are available over a complete orbit, and eclipsing double lines spectroscopic binaries. So that's about it, guys. These are just some classifications of star systems. Next video we're going to be talking about determining the mass of such a system. We're gonna be talking about the visual binaries, which we can derive the mass of the stars a lot easier than some others. And yeah, that's about it. Thanks for watching, guys.